Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, so let's start with these questions that concern our radiation graph. That's the one with intensity on our y-axis and wavelength on our x-axis. So first question on the left is which object is hotter, one with a peak wavelength of 400 nanometers or 700 nanometers? So in order to answer this question, all we need to know is that hot objects have a shorter or smaller peak wavelength. So this one here with the smaller wavelength is that 400 nanometers. So that one is going to be my hotter object. Okay, question number 2. Which object is hotter, one with a peak frequency of 300 megahertz or 500 megahertz? Okay, so now in order to answer this question, we need to know with these two frequencies which one actually has the shorter wavelength. So in order to decide that, I need to think about this equation that we did in waves earlier. So my wave speed v is frequency times wavelength. And since we're talking about electromagnetic waves, these waves are all travelling at the same speed or the same v. Therefore, if something has a higher frequency, the wave, it has a shorter wavelength. That's so when I multiply those two numbers, I always get that same value, v. So this means my larger frequency wave here has the smaller wavelength. 500 megahertz is larger than 300 megahertz, so the 500 megahertz, my larger frequency, has the smaller wavelength and is therefore hotter. Okay, so these two tables here, I have wavelength and intensity, and I need to find which object is hotter and give 3 reasons why that must be the hotter object. Okay, so the first thing I'm going to look for is which one of these two objects has its peak wavelength, that is its wavelength at its highest intensity as a smaller wavelength. So I can see my left-hand object here at a wavelength of 100 has the intensity of its peak wavelength, 50, that's the largest of all the intensities for that object. And on my right-hand side, the largest intensity is this 5 here, and that happens at a wavelength of 150 nanometers. So that's my first clue to say that the object on the left-hand side is hotter. Okay, what about my second clue? My second clue is going to be to do with what is the steepness of the curve. And the steeper the curve, the hotter the object as well. And if I look at my object on my left-hand side, my intensity goes from 5 to 50 in that wavelength change of 50 as well. So that's quite a steep increase, whereas on my right-hand side, it only goes from 4 up to the peak wavelength of 5 in that same 50 change of my wavelength there. Okay, and the third thing that I'm looking for is to look at all the intensities and see for a hotter object, the wavelength should have a higher intensity at all intensities. So if I look at the first one, wavelength of 50, one on the left is 5, one on the right is 4. Then at 100, I've got 50 versus 4, 150, 10 versus 5, 8 versus 4, and 6 versus 3. So all of my intensities on the left-hand side are higher than my intensities on the right-hand side. Okay, now for radiation and surfaces. Why is a wood painter painted matte black? Okay, so we know that matte black in particular is a good absorber and emitter of heat, and that's good for my wood burner because we want it to emit the heat out into the room. So that's why it suits its purpose. Okay, next question. Why do athletes cover themselves in foil after a race? So shiny silver, like the foil that they cover themselves in, is a good reflector of radiation. That means that the heat will be reflected back to the athlete. That's good because then they don't emit too much radiation too quickly, so they can actually cool down at a slower rate, because it's not good for athletes to cool down super quickly after their race. Okay, explain what is meant by the expression heat rises. So when we heat a fluid, what we are doing is we are giving the particles in the fluid kinetic energy. So they gain this kinetic energy, they move around more, which means that the particles start to spread out. Or another way of expressing that is saying that the fluid therefore expands. What that does is means that that area of fluid that you have just heated will become less dense because the particles are all now further apart from each other. And that means that that less dense fluid will rise, and then the colder, more dense fluid above it will sink down to take the place of that warmer fluid. Of course, then you can heat that colder fluid and it goes through the whole process again, so the process repeats, and that's how you get what's called a convection current. Okay, explain why water in a kettle circulates in currents as it is being heated. So what you'll find with convection is all of the answers to the questions are very, very similar, but you just have to apply them to that specific use. So here we've been given water in a kettle. So we know the water near the heating element is the bit that gains kinetic energy. Those particles spread out, so the water expands, and therefore that water rises and the colder water above it sinks. And because you have this process which is being repeated, that's how you get this current, this water circulating in your kettle. Okay, explain why solids are in general better conductors than gases. Well, first we need to think about what it means to be a good conductor. So what you have with a good conductor is you have the particles in that material vibrating. And what happens is the particles near the heat source begin to vibrate with these large amplitudes, and then they pass those vibrations on to their neighbours. And in that way, the heat moves through the material. So the point about solids is that their particles are really close together, so they can pass these vibrations on and transfer the energy easier. Okay, explain why cooking pans are often made of metal in terms of their heat transfer abilities. So you can go one better than a solid, which is to have a material like a metal. Why? Because metals have delocalized electrons in them. And those electrons can actually move through the positive ions of the structure. So what you get is those electrons actually bumping into the different ions and transferring the kinetic energy to those positive ions. So basically, it makes the whole process of this heat moving through a lot quicker in metals. Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not? So first one is all bodies emit radiation, and that is all bodies, even things that are cold, are emitting radiation. Okay, so that's really important and quite a common misconception that it's only hot things that emit radiation. No, it is all bodies. Power of radiation, yes, when you're talking about the average power of radiation absorbed versus emitted to explain increases or decreases in temperature or staying the same temperature, please do use the word power. That's very specifically telling me it's the energy per second, not just amount, okay, not the amount of radiation. Absorbers and emitted versus reflectors, yeah. So just to re-emphasize or point out that materials that are good absorbers are also good emitters of radiation. So those two things come as a pair, okay? It's my absorbers and emitters, the kind of matte and black surfaces that are good of those. And then reflectors, the opposite, my shiny silver, okay? But sometimes there's a misconception that something can be good at absorbing and emitting. Yes, it can. Matte black things are good at absorbing and emitting.